Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand how to run analysis of variance, that is one-way ANOVA in STATA. ANOVA is a statistical method used to compare means across three or more groups to determine if at least one group differs significantly from the others. In one-way ANOVA, means of more than three groups are compared. Group 1, Group 2, Group 3, and their means are compared. The null hypothesis for this is there is no significant difference in the means of more than two groups. The alternative hypothesis is mean of group 1 can be significantly different from mean of group 2. Mean of group 2 can be significantly different from group 3, and mean of group 1 can be significantly different from group 3. So the alternative hypothesis is there is significant difference in means of at least one pair. How many pairs are there? Three pairs are there. 1, 2, 3. And that's the reason we write this way. There is a significant difference in means of at least one pair. Key assumptions of ANOVA. Normality. The data should be approximately normally distributed. Homogeneity of variance. Groups being compared should have a similar variances. Interval ratio data. Variables should be measured on a continuous scale. Now let's see how we can run this in STATA, but first of all we will download one data set. So for this I will go in Google, I'll write down here HSB2 CSV, click on the first link, open intro.org, click here. Now this data set consists of 200 observations. Randomly sampled from high school and beyond survey, a survey conducted on high school seniors by the National Center of Education Statistics. 200 observations, 11 variables. The categorical variables are gender and their labels are female and male, race and their labels are African, American, Asian, Hispanic and white. Socioeconomic status is low, middle and high. School type, public and private. Program is general, academic and vocational. We are having a continuous data also, that is standardized reading scores, standardized writing scores, standardized math scores, standardized science scores and standardized social studies score. Now we want to download this data set, just click here, one CSV file, and on your right hand side the data has been downloaded. The same data we want to import in STATA, so go in STATA, file, import, text data delimited .csv, click here, browse, connect this HSB to here, open, click OK, and on right hand side you can see the name of the variables. Now run browse, so you can see the categorical variables such as gender, race, socioeconomic status, school type, program and the continuous variables. Now what is a research question here? Is there a significant difference in mean math scores between the programs? How many programs are there? Let's see. We are having the programs such as general program, vocational and academic. What is our null hypothesis? There is no significant difference in the mean math scores across the different programs. Three programs are there. So HO is mu academic is equal to mu general is equal to mu vocational. All program means are equal. Alternative. Just try to recall this word. At least one program has a different mean math score compared to the others. H1 can also be written as not all mu are equal. At least one pair differs. H1, mu academic is not equal to mu general is not equal to mu vocational. The means are not at all the same. Now we will have to check the normality first. So the null hypothesis is the variable math score is normally distributed. The alternative is the variable math score is not normally distributed. So we'll run the histogram for the groups. So histogram math by program and normal, the normal distribution. and we got the output: academic, general, and vocational. But we will have to run the formal test to conclude that is the data normally distributed or not. So for this, we will be running Shapiro-Wilk test, and the command line is by short program SWILK and math. So let's run this also. Enter. So we got the output for academic, general, and vocational and their respective p-values 1, 2, 3. Now let's do the interpretation. As the p-value for the academic program is this one, 0.1722, which is more than 5% level of significance, we fail to reject null hypothesis, which means that the math score is normally distributed for the academic program, this one. But for general and vocational, the p-value is less than 5% level of significance, which means we reject null hypothesis. So data is not normally distributed. In such scenario, we cannot run ANOVA, but just for understanding purpose, we will proceed further. Now we will have to check for the second assumption, which is equal variances. Null hypothesis, variances are equal across the groups. Alternative hypothesis, variances are not equal across the groups. STATA does not have built-in Levin's test command. So we are using ROBVAR, that is robust variance maths, comma by the program. So again, we will go in STATA, rob, and we got the output, the academic, general, and vocational. We do the interpretation on the basis of this 0.316. So let's see the interpretation. Look for the W50 row, that is a median based Levin's test, as the value for W50 is 0.316, which is more than 0.05. So we fail to reject null hypothesis, which means that the variances are equal across all the groups. This is desirable. Okay, that the variances are equal. See here, 1, 2. Now we will run the ANOVA, but the null hypothesis is there is no significant difference in mean math scores across the different programs. 3 programs are there: academic, general, and vocational. So HO is mu academic is equal to mu general is equal to mu vocational. All program means are equal. Alternative, at least one program has a significant different mean math score compared to the other. So H1 is not all mu are equal. So H1 is equal to mu academic is not equal to mu general is not equal to mu vocational. So at least one pair differs. So we'll run this one-way math program. So I'll write here one-way math program, enter. And we got the output. You can see here. Now let's do the interpretation. See this p-value. As the p-value is 0.00, which is less than 0.05, we reject null hypothesis, which means that at least one program has a different mean math score compared to the others. So now we will have to find out. So this can be done with the help of post hoc test. But before that, let us see that how can we run the ANOVA with the help of graphic user interface. So I'll go in statistics, linear models, ANOVA, one-way ANOVA. Response variable is math. The factor variable is a program, and press submit, and you will get the same output. You can see here, same output. Now let's proceed further for the post hoc test. For any two programs, we will have to do the comparison: academic versus general, academic versus vocational, general versus vocational. HO, mu I is equal to mu J. The mean math score of group I and J are equal. Alternative, they are not equal. The mean math score of groups I and J are not equal. So normally we run the Tucky's test. So what is the command line? Pairwise mean math over program and M compare effects. The M compare is multiple comparisons and this is pairwise means. So let's run this also. Enter. So it gives me the message string variables not allowed in option over. No problem. Program is a string variable. No need to worry. We will have to convert this string variable into the factor. So encode program generate program 2. Enter. Now in this program 2, enter, and we got the output. You can see here. So general versus academic, it's p-value. Vocational versus academic, it's p-value. Vocational versus general, it's p-value. So let's see the comparisons. As the p-value of pair, general versus academic, and vocational versus academic is 0.00, which is less than 0.05, we reject null hypothesis, which means that the match score of these pairs are significantly different. How much is the difference? -6 and -10. The p-value of the pair vocational versus general is 0.088, which is more than 0.05. So we fail to reject the null hypothesis, which means that the match score of this pair is not significantly different. The same I can run for Bonferroni also. Recall the previous command by pressing page up and write here Bonferroni. And I got the output. Now as the difference is significant, I want to compare their means. So this can be very well done with this help of command tabulate program 2, comma, summarize maths. So tabulate program 2, summarize the score of math, enter, and we got the output. So you can see those who are in academic program, their mean math scores are higher. In general, that is 50, and in vocational, it's very much less. Now the same thing, that is the pairwise comparison, can also be done from here. Go in statistics, linear models, ANOVA, one-way ANOVA, and only one tick is enough. You click on Bonferroni and press submit, and again you will get the same output. Just see here, -6.711, -10.311. So it's the same output which you got here. So this was all about how to run one-way ANOVA in STATA. For more videos on STATA, kindly refer to my playlist. I also uploaded many videos on data science, machine learning and artificial intelligence on my YouTube channel named Dhaval Maheta. To watch the full videos, please subscribe to my YouTube channel and check the playlist. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.